that the indefinite integral gives a family of functions called most general antiderivative. How does this look like? The integral, so it's the sum of those areas, but it's a stretched s of f of x dx equals the uppercase, the most general antiderivative, of x plus a constant c. That's the indefinite integral. Right now, we're going to talk about something else, something called a definite integral. This is the definite integral for continuous functions on the given interval. What does this mean? Well, first of all, let's define the definite integral. It looks exactly the same, but it's definite from a lower limit till an upper limit. It has nothing to do with the operator limit, from the low number to the high number. But we call it lower limit, upper limit, but has nothing to do with the concept of limit. So everything so far is the same, but it's on an interval. So a comma b is the interval where we are looking at the function. And the answer for a definite integral, again, what was the answer for indefinite? Family of functions, many functions. How do I check this? I differentiate f prime of x plus c, and I have to recover f of x. So the answer is a function or a family of functions. Now, what is the answer here? A number. So that's one of the first differences. When I am asked to find an indefinite integral, I know I'm asked to find a family of functions whose derivative is this one. So if we differentiate this, we get this function. When I'm asked to find the definite integral, it has to be, first of all, a continuous function. If this function is not continuous on a comma b, then we are moving into something else, okay, which is Calc 2. But in order to determine the definite integral for what we are studying in this class, the function has to be continuous on the given interval. If it's not continuous, we are not going to be able to find this number. Now the question is, how do I find this number? And then what it represents. Okay? So that's my next step here. To find the integral from a to b from f of x dx, we use, again, continuous function on AB, we use FTC. What is this? The fundamental theorem of calculus. Okay, how is this applied here? Fundamental theorem of calculus says this, that if I want to determine the definite integral from a to b from a continuous function on this interval dx, all I have to do is find its antiderivative, put a vertical bar from A to B. And what does this mean? How do I calculate this? What is the meaning of this? I plug in B and I subtract when I plug in A. So now we had a minute ago a function which was this. So here we had the function f of x, which is x squared plus 1. And we were given the interval 0, 5. And they were asking us compute, approximate, of course, approximate the area under this graph between 0 and 5 using these shaded rectangles. Now I will say, no. I will say, let's find the exact area. Not an underestimate using the leftmost point, not an overestimate using the rightmost point, the exact area. Okay. For finding the exact area, I will find the integral from 0 to 5 from f of x dx with the fundamental theorem of calculus. Not yet. First of all, I have to ask myself, is this function continuous on 0, 5? If you say yes, I can continue. If you say no, I cannot continue because the fundamental theorem of calculus will not be applicable if the function is not continuous on 0, 5. Is this function continuous on 0, 5? What type of function?
Yes.
Yes, it's a polynomial function. Polynomial functions are continuous everywhere. So then, can anyone give us the antiderivative of x squared? What function prime is x squared?
1/3 x cubed.
Excellent. Plus, can anyone give us the function whose derivative is 1?
Nice.
Excellent.
The total of 0.
So we found we don't need to, there is no constant here. And I can explain why in a minute. From 0 to 5. From 0 to 5. It says plug in 5 and subtract when I plug in 0. Okay, fine. There is no need to plug in 0 because it will be 0. 0 plus 0. I will only plug in 5. So 125 over 3 plus 5. 3 times 5 is 15. 15 plus 125 is 140 divided by 3. Exact. We have a way of determining this with a graphing calculator. Yes. Do I like it? No. But I'll show it. Yes. Any questions?
Could you just say what you just did again? I missed it.
Yes. 3 times 5 is 15. 15 plus 125 is 140. Is that what you meant here?
Yeah, so you're just adding.
When I add
Oh,
fractions, I have to find the same least common denominator. So since this has 1, I have to multiply this by 3.
So you're just doing the f of b minus f of a.
Correct. But f of
Okay.
a is 0. Because when I
Yeah.
plug in 0 here and 0, it happens that this time, because it's 0, the polynomial is 0.
Okay, thank you.
Thank you. Very good question. So, is there a way of doing this? Yes. For the indefinite? No. For definite? Yes. So, number 9. Aha. 0, 5, x squared plus 1, x, and it better give us 140 divided by 3. And we can check, there is no need, of course it's the same number. Okay, so I want us to practice this. That's all we are studying here. We're moving on to page 413. Where is my book? 413, 413. Let's see. So we're practicing areas and definite integrals. So choose whatever you want to determine and find the area under the graph of each function. All functions are continuous, of course, otherwise we cannot use the fundamental theorem of calculus.
Do 30.
Okay, so we want to, where is 30? Right here. Awesome. So let's start with 30. And we practice the fundamental theorem of calculus. And I'm on page 4. Okay, 30 is, make sure I copy correctly, y equals e to 2x, and the interval is -2 to 3. Perfect. Awesome pick. Good. So then the area under the graph will be the definite integral between -2 and 3 from e to 2x dx. Now, we do have a way of checking, right? Because we have the calculator. But there is no other way. If I didn't have the calculator, I wouldn't be able to check this. This has a great advantage. No matter what I find, I always differentiate to check my work. But here I cannot check my work unless I use the calculator. Good. So the fundamental theorem of calculus says find the antiderivative and then evaluate it from -2 to 3. Can anyone give us the function whose derivative is this?
E to x, 2x
Divided by?
2.
Exactly. Awesome. Thank you. So please leave the 1/2 outside. We plug in 3, e to 6 minus, we plug in -2, e to -4. If you want, we can approximate it plugging in the graphing calculator or not. This is the exact. If I plug it in, I will find an approximation. So I have 1/2, so 0.5. Close, open again, e to the 6th power, and then minus e to the -4. Careful with the negative you're choosing. Okay, let's see what this is. 201.71 approximately. Perfect. Let's move on. I would like us to practice the definite integrals with more examples. So we have a lot of definite integrals here, and then we look at a word problem. So anything you like. We can determine these areas if you like. Now here what I would like to say is the area can be negative. So if the area is under the x-axis, the result will be negative. We can look at this one. Here, there is more positive area above the x-axis than negative area. So the result will be positive. Here, these appear to be absolutely symmetric. A +5 area and a -5 area. So the answer will be 0 here. So we can work on any of these problems if you'd like to choose. And then I would like to practice more from 39 through 58. You,
36.
you wanted to start with 36? This one?
Okay.
No, I'm asking because I'm not sure I heard that correctly. Is that what
Yeah.
you wanted?
That's what I
36? Okay, so we continue with 36. Very good. So we have the integral from 0 to 2, as you see, from 0 to 2, from the given function. So this is x squared minus x dx. Perfect. So we know what we need to do. We have to find the most general antiderivative. So, and then we will evaluate it from 0 to 2. What function prime is x squared? We just had that a few minutes ago, x cubed over 3 minus. Which function prime is x? If anyone can help with that one.
X squared divided by 2.
Excellent, thank you very much. Of course, this time again, I'm not going to plug in 0 because this is 0 and this is 0. I'm only going to plug in 2. So I have 8/3 minus 4 over 2, which is 2. 6, 8 minus 6, 2/3. Any questions? Okay.
So that
Yes?
number is like,
Sorry?
that number is like the area.
Exactly. This
And
number, if you want to call it units squared, whatever the unit is. So this area is negative. This area is positive. So from this number, this was subtracted to get a total of 2/3 units squared. Feet squared, inch squared, whatever. Units squared, exactly. Good. Anything you'd like to choose from here? Of course, we are getting into a little bit
I
weird.
have a quick question.
Yes?